let's start from chapter 4, E1. A single force of 40 Newton acts upon a box 5 kilogram. The block. What is magnitude of acceleration of this block? So this force 40 Newton, which means F equal 40 Newton, and then this mass as M equal 5 kilogram. So F equal MA, or A equal F over M. So F is 40 Newton given, and M is 5 kilogram. Then you will get 8 meter per second square as your acceleration. Okay. The E2, a ball with a mass of 2.5 kilogram, M is 2.5 kilogram, is observed to accelerate at the rate of 6 meter per second square, which is acceleration A, right? And what is the size of net force acting on this ball? So F equal MA. So M equal 2.5 kilogram, and your acceleration is 6.0 meter per second square. Then you multiply, and then 15 Newton coming out as your force. Okay, the next one is E3. A net force is 20 Newton acting on the wooden block, produce of an acceleration of 4 meter per second square A. And then what is the mass for the block? So F A is given, F equal MA. Then you can write M equal F over A. Then F is 20 Newton, A equal 4.0 meter per second square, then 5 kilogram, your mass. Okay, the next one is E4, 3 kilogram block being pulled across the table by the horizontal force of 80 Newton. Force is 80 Newton, F, and M equals 3 kilogram. And also experiences a frictional force of 5 Newton is what is acceleration of the block. So block is there, that's 3 kilogram, and on the table, and then it pulled 80 Newton, and the frictional force is opposite direction. So F friction equal as 5 Newton, but opposite. So you can find F net equal F1 plus FF, which is 80. This we call as F1. Okay, 80 Newton plus negative direction of 5 Newton. Then 75 Newton. Then acceleration you need to find. So F net equal MA. So A equal F net over M. F net is 75 Newton. We found it from here. And then M equal 3 kilogram. Then divide, and then 25 meter per second square. Supposed to be your acceleration. Okay, the next question, E5. A pulled tablecloth exerted a frictional force of 0.6 Newton, a plate with 0.4 kilogram, and what is acceleration of the plate? Okay, so this surface, then there is a plate, this plate, and then this one is tablecloth itself is pulled this way. Between that frictional force is 0.6 Newton, right? So it full as FF equal as 0.6 Newton, because this table cloth is a pull, and then same time your plate moving. Mass of plate is 0.4 kilogram. So FF equal mass times A. So A equal FF divided by M. Then FF 0.6 Newton and M is 0.4 kilogram. Then 1.5 meter per second square, which is your acceleration for the dish by the tablecloth. Okay, E6, a 6 kilogram block being pushed across the table by the force P has an acceleration of 3 meter per second square. Acceleration A equal 3 meter per second square. Your force P you don't know yet. What is net force acting on this block? So F net equal MA. So M is 6 kilogram. A equals 3.0 meter per second square. Multiply and then 18 Newton as your net force. If the magnitude of P is 20 Newton, what is magnitude of frictional force acting upon the block? So P equal as 20 Newton. And then surface, and then there is a certain force of friction. This is you don't know, but you know the force F net equal 18 Newton, which is P plus FF, which is P is 20 Newton plus something negative something Newton, negative 2 Newton supposed to be. Then you will get your F net as 18. So F frictional force is 2 Newton, opposite side of moving. Okay. Okay, two forces. One is 50 Newton and the other is 30 Newton, and act in opposite direction on the box and as shown in the diagram. What is the mass of the box if acceleration is 4 meter per second square? Okay, the box, one side is 15 Newton, F1, and F2 equal 30 Newton. But magnitude is this, and then direction is the opposite side, right? Then after this, M you don't know, but you know acceleration equal 4 meter per second square. Then F net equal F1 plus F2. F1 is 50 Newton plus negative 30 Newton, becoming 20 Newton as net force, which is F net equal M times A, and M equal F net divided by acceleration, right? F net is given as 20 Newton, A is 4 meter per second square, then 5 kilogram as your mass. Okay. Okay. E8, a 4 kilogram block is acted upon by the 3 horizontal forces as shown in the diagram. And what is net horizontal force acting on the block? Okay, there is no diagram on here. 4 kilogram and one force, F1 equal 20 Newton and F2 equal 10 Newton, F3 equal 15 Newton. like that, and then we can find it. Okay, F net equal F1 plus F2 plus F3, which is 10 Newton, 20 Newton plus 10 Newton plus negative 15 Newton, because one is opposite direction. Okay, then your net force becoming 15 Newton, right? And then what is the horizontal acceleration? So you need to find A. F net equal ma. A equal F net over m. So m is given as 4 kilogram, and then F net is 15 Newton. 4 kilogram. Then 3.75 meter per sec square, which is your acceleration. Okay. Okay. Next question is E9. 4 kilogram sled. 4 kilogram sled sliding freely on the ice surface experience 2 Newton of frictional force exerted by the ice, and air resistance is 0.5 Newton. What is net force acting on the sled? Okay, 4 kilogram sliding freely, 4 kilogram and sliding freely, and the supposed to be some motion there, and then friction of your surface by ice, F friction equal 2 Newton, and also air come this way, air resistance also F air equal as 0.5 Newton, opposite direction of motion, right? So F net equal negative 2 Newton plus negative 0.5 Newton, because opposite direction. So negative 2.5 Newton of net force is acting on it. And then what is acceleration then? F net equal ma. So A equal F net over m. M equal 4 kilogram already given, and then your net force 2.5 Newton. Then you have negative 0.625 meter per sec square. Negative direction means deceleration, because net force is a negative direction. Okay. Okay. What is weight of 40 kilogram mass? Okay. F weight, or equal mg, right? Weight equal mg. M equal 40 kilogram. G equal on the earth 9.8 meter per sec square, which is the force, right? Then 39.2 392 Newton, not point, 392 Newton, which is your weight, Fw, by the gravity. Okay. Okay, the next question is, what is mass of 196 Newton weight? Okay, F weight equal mg, right? M equal F weight over g. So F weight is 96 Newton, and g is 9.8 meter per sec square, and 20 kilogram as your mass. Okay. Okay, the next question is, Jennifer has a weight of 110 pounds, and what is her weight in Newton? And 1 pound equals 4.545 Newton. So F weight equal 110 pound times how many Newton in 4.45 Newton in 1 pound. Pound cancel, and then you can calculate. Okay, 110 times 4.45, then you will get 489.5 Newton. Okay, and what is the whole mass in kilogram? F weight equal mg. M equal F weight divided by g. F weight is 489.5 Newton divided by 9.8 meter per second square, and divided by 9.8 equal 49.95 kilogram is your mass, Jennifer's mass. Okay. Okay. Next question is the E13. The author of this text has a weight of 600 Newton. What is his mass in kilogram? F weight equal mg. M equal F weight over g. So F weight is 600 Newton and divided by 9.8 meter per second square. Then 600 divided by 9.8 equal 61.22 kilogram. And what is his weight in pounds? Okay, in that case, F weight equal as 600 Newton, and 1 pound equal as 4.45 Newton. So 600 divided by 4.45, then you will get 134.83 lb per pound. Newton cancel, and you get it. Okay. Okay, next question is who has a larger mass, a man weighing 145 pounds or one weighing 735 Newton. Okay, F weight as 145 pounds equal 4.45 Newton per 1 pound, right? Pound cancel, and then 145 times 4.45 becoming 645.25 Newton, and the original weight is 700. Another weight is 735. So 735 Newton is heavier than 145 pounds in this question. Okay, the next question. At a given instant in time, 4 kilogram rock that has been dropped from the high cliff experience a force of air resistance of 15 Newton. And what are the magnitude and the direction of acceleration of the rock? Okay, 4 kilogram rock is dropped, and the gravity of this is 9.8 meter per second square, and then it experiences air resistance, right? The force of air resistance is 15 Newton, opposite direction of motion, right? Then the actual force on this, you can find the net force, right? F net equal Fg gravity plus Fa, but the Fa and Fg is opposite direction. So Fg equal mg plus Fa. So m 4 kilogram times 9.8 meter per second square is downward. So we put negative here. and the opposite direction of the gravity is positive 15 Newton for this. So 4 times 9.8 equal negative 39.2 Newton plus 15 Newton, then minus 15, then 24.2 Newton as negative direction. Then F net equal m times a. A equal F net divided by m. So F net is negative 24.2 Newton divided by 4 kilogram. Then divided by 4. Then negative 6.95 meter per second square is the acceleration, which means going downward at 6.95 meter per second square. Okay, the next question is E16. A given instant in time, 5 kilogram rock is observed falling with an acceleration of 7 meter per second square. What is the magnitude of force of air resistance acting upon the rock at this instant? Okay, so F net equal m times a, which is your 5 kilogram times 7 meter per second square as negative because of falling, so negative 35 Newton. Okay, then also F net is Fg plus F air resistance. Then Fg equal m times g plus Fa. So we need to find this Fa. So m is 5 kilogram and g equal negative 9.8 meter per second square plus Fa equal negative 35 Newton. And this going to the other side, so Fa becoming negative 35 plus 49 becoming 14 Newton as your final answer. Okay, the next question is 0.5 kilogram of book rest on table, and a downward force of 6 Newton exerted on the table of the book by the hand pushing down on the book. What is magnitude of gravitational force acting upon the book? Okay, so on the table there is one book, the mass equal 0.5 kilogram, and the gravitational force is G, 9.8 meter per second square. Okay, so your Fw, which is m times g, which is 0.5 kilogram times negative 9.8 meter per second square, then 4.9 Newton as negative. That is your force. And what is magnitude of upward or normal force exerted by the table on the book? Is the book accelerated or not? Okay, and then this book, 0.5 kilogram book, is pushed by 6 Newton and also pulled down by negative 4.9 Newton, negative 6 Newton downward, right? And so which means this table supposed to be supporting all and then not moving, which is no acceleration. Okay, F net supposed to be 0 by Fg plus this, we call it F1 plus the normal force we call as F normal. So Fg equal negative 4.9 Newton plus F1 is negative 6 Newton plus Fn becoming 0. So Fn is 10.9 Newton to cancel all out, which is your normal force. There is no acceleration as well. Okay, the next question is E18. Upward force of 18 Newton is applied by string to lift a ball with a mass of 1.5 kilogram. 1.5 kilogram of ball is pulled by 18 Newton of F1. And what is net force acting upon the ball? And this ball applied 18 by the string, and also this applied by gravity as well, negative 9.8 meter per second square. So F net equal Fg plus F1. Fg equal mg plus F1. So m equal 1.5 kilogram, and your acceleration, gravity is 9.8 meter per second square plus 18 Newton. Then you will get F net, which is 18 minus 1.5 times 9.8 equal 3.3 Newton, which is your net force. And then your acceleration, you can calculate F net equal ma. F net is 3.3 Newton, and also you can recalculate as A equal F net over m. F net is 3.3 Newton divided by 1.5 kilogram divided by 1.5, then 2.2 meter per second square as your acceleration, net acceleration for the ball. Okay, now 60 kilogram of woman is elevator is accelerating upward at a less rate of 1.2 meter per second square. And what is the net force acting upon the woman? Okay. The accelerate 60 kilogram of woman, then this radius is 60 kilogram, and then this radius supposed to has pulled by gravity equal negative 9.8 meter per second square, and then F1 equal, you don't know, right? F1 equal, you don't know, but you know F net equal ma, which means m equal 60 kilogram times 1.2 meter per second square, which is 72 Newton upward. And then you can find the gravitational force acting upon the woman, which is Fg or Fw as weight, mg, which is 60 kilogram and negative 9.8 meter per second square, and 60 times 9.8 equal negative 588 Newton. Negative means downward. Okay, what is normal force pushing upward on woman's feet? So woman's feet is supporting, so it's supposed to be your net force like this. woman's feet is acting gravity. That gravity is supporting, and its net force is coming up, and that net force also adding upon it the reaction, right? So your F normal supposed to be F net plus negative Fg. So which means 72 Newton plus 588 Newton, which is plus 72, becoming 660 Newton as a normal force upon it. Okay, that is the last answer. Okay, thank you and bye now.